The normalization theorem for the simple tier of types translates in intuitionistic propositional logic. The idea is to reduce a proof by eliminating the redundant steps. The measure premise of an elimination rule is the one containing the connective to eliminate. It is clearly redundant to introduce the connective in the measure premise of an elimination rule. These redundancies, or detours, are reduced by the detour conversions illustrated in the slides. Since not A is A implies false, the detour rule for the negation is the one for implication. There are no detour rules for true and false, since these connectives lack an introduction or an elimination rule. Rewriting these rules in the simple tier of types, they become the reduction rules for typed terms. In a disjunction elimination, we may prove the conclusion in a branch without using the assumption to discharge. This introduces a redundancy. The purpose of the simplification conversions is to get rid of these redundancies. It is of no use to deduce false by false elimination from a false premise. Simplification conversions eliminate these redundant steps. Disjunction elimination hides detours and simplifications when it is used to derive the measure premise of an elimination rule. Hence, we want to move disjunction eliminations downward, revealing hidden redundancies. This process is performed by the permutation conversions. Look at the first conversion in the slide. It permutes the OR elimination with the AND1 elimination. The other conversions are similar. These conversions, applied in the right order, allow to prove the normalization theorem. Every proof can be reduced to a proof in normal form, that is, a proof in which no conversion applies. The first important consequence is the subformula property. In a proof of A from gamma in normal form, all the formulae in the proof are subformulae of some formula in gamma and A. By looking at the structure of the proof of the normalization theorem, we see that the last step of a proof must be an introduction rule except when the conclusion is atomic or false. As a consequence, disjunction is decidable. And also, in first-order logic, existential statements have a witness. It is essential to remark that the normalization theorem holds for pure logic, either propositional or first-order, and for natural deduction. Choosing a different deduction system may falsify the theorem. Even with natural deduction, adding a theory, so instances of the axiom rule, may lead to falsify the theorem or may lead to different normal forms. In these cases, the constructive nature of intuitionistic logic is not automatically achieved. As a counterexample, consider that classical logic is just intuitionistic logic plus the theory containing all the instances of the law of excluded metal.